Hey everyone, welcome back to eCoreAcademy. It's me, Ranen Shakir, back with you with another pre-algebra video, and this time we're covering the different types of numbers. Before we start, make sure to leave a like, subscribe, and leave any comments down below, and check out our socials in the description. So this lesson is not really application-based, since this is more of a concept that will be used in further applications in this course and any other math class ever. So the different types of numbers, what this about. So I have this little graphic here. It says, so you're telling me that there are different types of numbers now? Yeah, that's exactly what I'm telling you. There are more than just your 0, 1, 2, 3, 4, 5. There are a whole different types of numbers, some of which we won't even talk about in this class, in this course, which are used further on in higher level math. So without further ado, let's get started. So these are two graphics that we will come back to so we can kind of, especially the first one, to like see how everything is intertwined. So the first one here is like a family tree of all the different types of numbers, and this one here is like an oval kind of thing. It like expands on from like the natural numbers, then integer, then rational, and then irrational, and then real numbers, which I'll go over in this video. So let's just start with the most basic type of numbers that we use all the time, which are natural numbers. Natural numbers are also called just positive or counting numbers. These are the numbers that you count when someone tells you to count to 10. You count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and on and on and on. So these are what natural numbers are. It's important to know that natural numbers do not include 0. That is a different type. Those are different types of numbers, and the numbers that do include 0 are whole numbers. So whole numbers are natural numbers, everything natural numbers, plus 0. So this little graphic is a good example. To make sure you understand, the number line goes on forever. All these numbers go on forever. There's no end. So natural numbers, as you can see, are 1, 2, 3, 4, 5, 6, 7, 9, 10, and on and on and on, minus 0. And then whole numbers are with 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's how you distinguish both. Whole numbers have 0, natural numbers do not have 0. So let's move on to two other types, which you've probably seen before, one of which are integers. This is a set of all whole numbers plus negatives. So this is your 0, 1, 2, 3, 4, 5, on and on, plus your -1, -2, -3, on and on. So the way we distinguish integers from whole numbers and natural numbers is that they also include the negatives and 0. 0 is an integer. And then this next one we have here are rational numbers. So rational numbers are any number that can be written as p over q. What this means is that a number that can be written as a fraction or a ratio. So some examples here are 1/2, 1/3, 4/5, 0.5, which is the same thing as 1/2, 1 over 1, which is the same thing as 1, because anything over itself is 1. And then we have 0 over 1, and anything 0 over anything is 0. So that's those are rational numbers. And here is our little expanding bubble that we have. We just talked about whole numbers and natural numbers, and now we expanded to integers, which are all negatives plus all whole numbers, and then rational numbers, which are anything that can be written as a fraction or a ratio, as we see here and as we see here. So there are a bunch of other examples in the rational number column and the integers column. So like we have 1/3, 3 4/5, negative. It's important to know the negative numbers are also rational numbers. 12 over 73, -2 over 7, and just anything written as a p over q or as a fraction. So let's move on to two other types. Let's talk about irrational numbers. These are numbers that cannot be expressed in p over q, which means a number that cannot be written as a fraction or a ratio. Some examples are pi, because pi goes on forever. The square root of 2 that has no definitive value, that goes on forever. The answer to that, if you put the square root of 2 in a calculator, it'll give you an endless decimal. E, which is another type of constant number like pi, which also goes on forever. Square root of 11 is an example, and the cube root of 13 another example. These numbers go on forever. These numbers go on forever, there's no end. Therefore, you cannot write them as a fraction or a ratio. We will talk about irrational numbers in this course. Like we will do operations and everything with them, especially when we get to the further chapters. And then we have real numbers. This is what everything kind of every number that we talked about so far branch into. These include all numbers that can be written as a decimal, and in other words, every number we just talked about. Yeah, so if you put these numbers, like these irrational numbers here, like pi, root 2, and e, root 11, they will come out as decimals. Therefore, they are real numbers. They're not real numbers. They're real numbers. They're just irrational. They're not rational numbers. So here are the examples here again. See, pi is a real number, 3, -5, root 2, right here, 1.5, 1/2, and on and on and on. Any number, if you put it in a calculator, comes out a decimal, that's going to be a real number. So here's the little family tree we got so far. So we will go over the entire family tree at the beginning in just a second, but see, we have real numbers here. We have rational numbers, irrational numbers. Irrational numbers are right here, cannot be written as a fraction or expressed as a form P over Q. Understand this P over Q is very important. It's a number written as a fraction or ratio. And then we see rational numbers, integers and non-integers are also rational numbers. Negative integers, whole numbers, those are integers, which means they're rational numbers, which mean they're real numbers. And then zero and natural numbers are also rational numbers and real numbers. So we'll go over this huge, big one in a second, but we have two more that we need to cover real quick. One of them is imaginary numbers, which we will not be using in this course, but it's important to understand it. So an imaginary number is a complex number that can be written as a real number multiplied by imaginary unit I. This might make no sense to you. That's okay, because it's not something we need to learn right now, something you learn in Algebra 1 and 2 and further on, but I'm just trying to introduce it to you so you understand it. So this is where A and B are real numbers and I is imaginary. Let me show you right here. So A and B are the numbers that are not I. So for example, I itself is a complex number because it's imaginary, because it's not a real number. We have I squared, root 2, root of -2, because you cannot take a square root of a negative number without using an imaginary number, which is, again, something you don't have to worry about. Then we have 3i. So that's what the a, b means. So a and b are basically coefficients and multiplied with the I. So what a complex number is a number that is written in the form a plus bi, where a and b are real numbers and I is imaginary. So 7 plus 3i would be a complex number because the 7 is the a, the 3 is the b, and the I is the imaginary, making it a complex number. The square root of 2i, -4 minus 4. These are examples where a and b. The a would be the first value, the b would be the one attached to the I, and then the I is the imaginary number. So you can see how complex numbers are different from real numbers, and they don't fall in the same category since they follow a different set of rules. So now let's go over this big family tree we talked about at the beginning. So we have all numbers. These are all numbers ever known. So then we have it branches off into real numbers and imaginary numbers. See how imaginary numbers are different from real numbers because they follow a different set of rules and they have different properties, and you don't use them in regular arithmetic operations. They're different. They're a whole different concept and idea. I just want to introduce it to you because you do learn it later on in math. So we're not going to worry about imaginary numbers this course. We're only going to focus on all the real numbers we have here. So everything that branches off of real numbers are real numbers. So if a rational number, if you just talked about, something that cannot be written as a decimal. Something cannot be written as a decimal or a fraction or a ratio. And we have rational numbers, which can be written as a P over Q. And then rational numbers, we have fractions, and we have proper and improper fractions. We have a whole unit on fractions, so we will go over what all this means. And then we have integers, which are negatives and positives and 0. And then we have, right here at negatives, and positive and whole numbers. And then in the positive and whole numbers, we have the natural numbers, which are 1, 2, 3, 4, 5, not including 0. And then we have 0, which is a whole number, not a natural number. So I want to touch on this real quick. Prime and composite numbers. These are real numbers. So whole numbers greater than 1 that have only 2 factors are prime numbers, and which means that the prime numbers, the multiples of the factors of prime numbers are 1 in itself. We will go over factors and multiples. There's a whole unit on that. That's actually the next chapter. So we will go over this. If you don't understand this right now, that's okay. We will go over that in the next chapter. So we have 2, 3, 31, and 13. So the only number, what this means is the only numbers that can give you 2 are 2 times 1. the number itself and 1. That's why it is a prime number. The only multiples that can give you 3 are 3 and 1. 31, 31 and 1. 13, 13 and 1. I hope you kind of see the pattern there. The only numbers, and that's what it means. 1 in the number itself is a prime number. Now, composite numbers are integers that can be formed by multiplying two smaller positive integers, which means they have more than one factor. So 4, 6, 12, 49, 100, you can multiply 4 by 4 times 1 and 2 times 2, making it a composite number. There's more than one multiple for that number. 6, 3 times 2, 6 times 1, 12, 6 times 2, 3 times 4, 12 times 1, 49, 7 times 7, 49 times 1, 100, 10 times 10, 100 times 1, 5 times 20, 25 times 4. So they have more than one factor, therefore they are composite. So there, as you can see, there are more composite numbers than prime numbers. That just makes sense how it works out. And we will go over this in the next chapter, which deals with multiples and factors. That is it for the video. Make sure to like and subscribe. This was a shorter video and is more conceptual because there's not really math involved with learning the types of numbers, but there is math involved with the types of numbers, which we'll obviously do later on. So thank you for watching again. Make sure to like and subscribe. Our website's right here if you have any want to check it out, see what other courses we offer. Our email is right here. Feel free to leave an email with any questions, comments, and concerns, and all of our other socials are in the description below. You can go check out some of our posts and our other teachers and other videos that we offer. So thank you for tuning into this video. I'll see you next time with our last video on chapter 1, and then we will move on to chapter 2 after that. So thank you again. It's been Ranen and Shakir. I hope you have a great day, and I'll see you guys later. Goodbye.